Good afternoon, everyone. Welcome to yet another session of the course titled Artificial Intelligence in Industrial and Management Engineering. I am Dr. Deepafale from IIT Kanpur, and along with me Dr. Prabal Pratap Singh is co-teaching this course to you. And what we are looking at is few tools and techniques that are very commonly used in industrial and systems engineering problems, specifically in the area of business and management. Where you can use certain tools to address some of the pressing problems. So, yesterday when we concluded the lecture, if you look into it, we talked about the 6 R's. So, the 3 R's, number 1 being reduce, reuse and recycle, which are the existing, the popular established 3 R's of eco-efficiency, or how do we, eco-efficiency is being less bad. So, how can you be lesser bad? That is what we discussed yesterday. Then we talked about refine and recover as the 2 new R's that is proposed to augment the eco-efficiency, and then re-innovate as the last tool. So, today now let us look into the next concept that is coming up very popular in the world. It is cradle to cradle. Okay. So, cradle to cradle is considered as the first logic here is a manufacturer is responsible for the product throughout its entire life cycle. And we mentioned what is a life cycle. The life cycle starts from idea, concept to what we call as, I will call it as prototyping, then manufacturing, usage, disposal. Okay. So, all aspects, this entire life cycle. So, this is the beginning, this is the cradle, okay. This is at your birth stage, and this is the end. Okay. So, this is your to grave kind of a thing. But then in the circular economy, what happens is you start here and then you come in back again here. So, the cycle begins. So, where you take the disposal and goes back into the conceptual phase. Okay. So, the logic here is that create products that are designed for upcycling. Okay. People always conclude this or confuse this word. So, what is this concept of upcycling? Okay. There is many definitions to this, but the simplest way to look into upcycling is, I will put it this way. This you can think about it as a similar to biological nutrient cycle. Okay. So, nutrient cycle, what happens is the nutrients, they form cells, cell becomes tissues, tissues become an organism, organisms leave and then they die, then the cells decompose, it goes back to nutrients and then they get back into the same cycle. Okay. So, similar to the biological cycle, what we call it as the technological nutrient cycle. Okay. So, that is in the products that you are doing a technological nutrient cycle is what we talk about this. So, the logic is, the underlying logic is, it is no waste. Okay. It is not less waste. The concept in the life cycle is different to what we call as eco-efficiency. Okay. So, it is what we call as ignore being less bad. Okay. Focus on not bad. That is the logic here actually. Okay. Do not worry about just being less bad, focus on not bad. So, but in a production system, as we said earlier, you have inputs and you have a transformation process, okay. You have outputs, and we also mentioned about feedback, but the issue here is that this system, when we talk about this, okay, we want to make sure that whatever the inputs and outputs that goes in, it is not just being less bad, it is not bad. That is the other focus. So, then when you do that, obviously there are some considerations. You have to also make sure that it is economically sustainable. Okay. Economically sustainable in, so the main questions, A, who is paying for the product? For your product. So, the first question is, you have to answer is, who is going to pay for your product? Is it the user or is it the government? Government usually means subsidy in this regard. Who is going to pay for your product? Okay. Second question you will have to answer is, will they keep paying or will they continue to pay? Will they continue to put money into do what you have said to do at this point? Then the question is, if so, if they continue to do so, why? Okay. That this implies, why would the stakeholder continue to pay? Okay. This is a big question. Okay. Why should they continue to pay for this more expensive, more or technological nutrient cycle based product that you need to do? Okay. Then the last part is, you also need to think about is, what is the value? What is the value the product brings? Okay. So, an example of it is, okay, it is normal car which is ICE, internal combustion engine, versus Tesla electric car. Okay. As a product, what does the value that Tesla brought onto the table? That is something that is of quick importance in this regard. Okay. So, and then the question usually arises with this is, in the management or the industrial systems aspect is, do I need to spend this additional amount of money? If I do that, when will I get the return? What will be the ecological impact? Is the tangible and intangible cost is going to give better benefits? Those questions are very difficult to answer, business questions. To answer them, if you have some level of data and patterns are available, then AI can probably do better aspects or better findings in this regard. Okay. Now, let us talk about markets also. We are not going to spend too much time in this course about markets, but some important aspects that you need to consider, because we will talk about markets in many places. The first thing that we all should know about is, people will only pay for things that they actually want. Okay. People will only pay for things that they actually want. They will not, this actual want is critical. Okay. Second is, it should be measurable. Okay. There is a management phrase, you cannot manage what you can't measure. Okay. So, the measurable, the famous adage, you cannot manage what you can't measure, is a very critical point as part of this. Now, the third point is what you call as a reality check. Okay. You can say that you can dream, but be realistic. If you bring a new product into the market and you say, well, this is much better than the other product, so then, and people will buy like thousands, you can dream that way, but you need to be able to be realistic to figure out how much the customer will buy. Then markets can also be an efficient method of allocating resources. Okay. It can be, markets can be an efficient method of allocating resources. So, what happens is, if your product is really good and people really want to it, more people will come and invest in your company. So, money, materials, methods, all those resources that you are talking about can be allocated. If the market is better, you actually get better allocation of resources. And there is one more thing, in market you need something called as discipline. Okay. And it is, okay, discipline means it's like be realistic and respectful. Okay, rather than pleasing oneself. Okay. So, what does that means is, be realistic, look at what the system is doing, and then be realistic and respectful. Okay. Understand, if the market is telling that your product is not good, your product is not good, accept that, and then do necessary changes. Okay. So, now let me show you an example. Okay. This is an example taken from based on Toyota system, Toyota production system. So, if you look into this, you have something called as the parts and material suppliers. Let us start from here, let us start at this point. Okay. The parts and material supplier, so the manufacturer, okay, will procure, okay, from the supplier and then will procure and will use logistics. The manufacturer will procure and will use logistics. So, from the parts and the materials they will procure and then they will use the logistics to come to the production. So, logistics, what will happen here is, it will transport, okay, it will move to the production. Let us take this example as Toyota for the time being. So, Toyota has what they call as TPS, okay. TPS stands for Toyota Production System, okay, or the common phrase for this is called as JIT, just in time. So, the parts, the materials, the sub-assemblies, everything will come into the factory just as and when it is needed. So, this means no inventory or no stock. Okay. So, that is the logic behind the, we can discuss this for other courses, but the fundamental logic is that. Okay. So, they have done the design and the development of the product and they have their factory in which they have done a Toyota production system, where they use the raw materials and parts that are shipped to their factory to produce. And then what will happen is, this is finished goods. Finished goods. What is the finished goods? Cars, SUVs, etc. Okay. So, that gets shipped out. So, this logistical, we use the word ship because usually the finished goods are typically shipped, not transported. Transport is raw material. This is terminology, by the way. And then this shipment goes to the dealer. Okay. And dealer, basically what we have here is the concept called interact. Okay. They interact with the customer, it is both ways. Okay. So, the dealer interacts, the customer also interact, but customer utilizes the dealer for what? The dealer will do
sales, the dealer will also do what we call as maintenance, the dealer will provide warranty. All those functions will be done by the dealer for Toyota, and Toyota works closely with the dealer. So, they gain knowledge from the Toyota who is manufacturing it. And what does the customer do? Customer uses it. Okay. And then after the user, customer can, what they will do is they will transfer, they will sell the car to somebody. Okay. So, this is a reuse. Reuse means used vehicle, what we call a second hand. Okay. Somebody can reuse the vehicle, they will run it for more time period, they do all those kind of things. And then finally, disposal. Disposal means vehicle reached its end of life. Okay. So, then from that point you separate parts. Okay. You extract materials. Remember, I talked earlier about the nutrient cycle in this example, biological nutrient cycle. This is the point at which we are extracting materials, sub-assemblies, etc., where you are actually creating the technological nutrient cycle. So, the technology nutrient cycle comes here. And the recycling company, what they do is they recycle and then they again now call it as transport. They transport the, can be parts, the materials, etc., to the, so they may be transporting the scrap iron which is melted and redone for them to make the body parts. They may be transporting things like plastic pellets which can be used for creating what we call as the plastic components of it, etc., etc. So, then the again once the procurement person will have, again the transportation comes into picture. Okay. So, the cycle, now you can see that the complete cycle is actually works out of it. Now, another aspect of it is what are the major resources that we will end up using in this. One is water. Water is used for production, which is machining, cleaning, etc. Okay. Then we use energy to run machines, factory, etc. Okay. Then fuel, which is the usage, okay, run the car. To use the car you need the fuel, and raw materials obviously is to transform. You use raw materials and you transform them to the finished goods. So, these are the major ways. So, water you may be used as an accessory in your cleaning the part. You may be also use the water to wash your car. Okay. Same way, energy, you may run the factory, you may run the lights, you may run the air conditioner, you may run the lights in the toilet, flush system, etc., etc. So, energy will come in different forms to make sure that, so it is not just the factory, it is also the energy that is used in the dealership is also an aspect of it. So, when you look into this, now you can see all these data that we collect, and if we want to quantify the greenness or sustainability of a product, it is a very complicated game. So, now you have a huge data set which is a big data. So, then to analyze all of this and quantify or identify necessary or valuable information out of this, you would require complex models, and this is the areas, one area in which you can think about where AI will actually play a key role. Continuing this, so from this let us use the example of Toyota. They will give you some tangible measures that Toyota was able to achieve as part of this. So, one of the things that they have done is average energy consumption per vehicle produced. that is 27% reduction since 2000. So, this means if the car required 100 units of energy, now it requires 100 minus 27, that is 73 units only. Okay. So, the average energy consumption has considerably reduced. They were able to achieve by this. Okay. Second thing, metric tons of carbon dioxide CO2 per vehicle produced. Okay. For every car they produce, okay, they have 23% reduction since 2000. So, which implies if 100 tons of CO2 in 2000, it is only 23% reduction. So, that is 77, right, 77 tons. Now, then third one is average water consumption per vehicle produced. Okay. So, for every vehicle that they produce, they have been able to reduce the water consumption per. They did 26% reduction since 2000. So, that means 100 liters now become 74 liters. So, earlier in 2000 if you required 100 liters, now it has become 74 liters. Okay. Then non-saleable, okay, saleable waste per vehicle. So, once you produce it, the waste that you are producing per vehicle produced, the waste that you are producing per vehicle that nobody wants to buy from you, okay, 46% reduction since 2000. Okay. So, that means earlier they were doing 100 tons of waste, now reduced to, so that is 46%. So, that will be 54 tons. So, a classic example of it is plastic pipe caps. These pipes are used in cooling, then fuel circulation, etc. Okay. Plastic pipe caps 100% recycled, okay, 3 tons daily. That is a huge achievement when you think about it, because people have been able to solve this problem, or Toyota have been able to solve this problem in such a manner. So, now if you look back in the previous slide I mentioned, you can see there is water, there is energy, there is fuel, there is raw materials, which are the resources which we talked about as part of the nutrient cycle. You can see in this slide that they have focused on water consumption, they focused on energy consumption, they are focused on waste, which is raw materials, and the carbon dioxide. Where would the carbon dioxide come in this previous one? Energy. So, since they are able to reduce the carbon dioxide, that means they have also been able to reduce the energy as part of it. Now, extensive use of data analysis and pattern recognition to identify innovative solutions. So, some of the AI tools that are used in pattern recognition or data analysis, large scale data analysis, so learning models etc., heavily were used to come up with these innovative solutions that allowed the company to achieve such huge reductions. So, that what happens, if you think about it, the logic is, we said earlier, productivity is the ratio of outputs over inputs, right. So, if you are able to even maintain the same level of output, but reduce the input, this will increase productivity. Okay. So, Toyota has been focusing on lean quite a lot, lean manufacturing. When people talk about lean manufacturing, that is what they have been able to achieve, and all these outcomes are as part of their lean achievement. And lean achievement did not happen over time. They measured everything, they quantified everything, used the help of learning models, pattern recognitions, decision trees etc., to identify small increments in which you can actually achieve large savings, so that your productivity actually improves, increases your productivity. Now, let us take another example, second example, and this is also again taken courtesy Toyota, but it is a good example. So, what happens is that typically a car comes to, let us say, a paint booth. Okay. So, what it does is so car comes here, this is, let us call it as a paint booth. Okay. Then you have some portions where you have cleaning, then you have primer, then you have drying, then you have painting, then you have what you call as clear coat, etc. I mean, broadly saying this, and then painted car comes out, or painted car comes out, okay, leaves the paint booth. Now, one of the critical aspect of this is the drying process. Okay. This requires an oven, a drying oven. Okay. So, the two things. So, what they try to come up with this is, why should I, if I can change the primer. So, what Toyota did is, Toyota tried to find out, design a primer that actually would be able to dry the paint or able to manage the painting without using an oven. Okay. So, eliminate oven, okay, remove it, eliminate oven, then paint directly onto primer. Okay. So, the primer portion, this is sometimes known as BIW, which is called body in white. Okay. So, they made sure that the drying oven is eliminated, and if you eliminate the drying oven and paint directly into this by using better chemicals. So, when they did that, they were able to do 15% reduction in energy usage, because the drying oven went away. So, now your energy usage is reduced by 15%, and this 15% reduction is what they have done is, this is done with this process is called as process re-engineering, or some people call it as process improvement. Okay. So, the one of the focus has been identify better chemicals or better primer that allow you to do wet painting. Okay. So, this is called, this approach, this new approach, they call it as 3 wet, okay, is what they started calling it. So, it is just the wet painting which actually allowed them to eliminate the requirement, eliminate the need of a drying oven thereby saving 15% reduction in energy. So, I am giving an example. So, now when you see many such strategies done by different companies, imagine collecting all of them in a place, and then you have a learning system that actually learns from it and suggests you a combination of strategies that you could try, where you may be able to learn from somebody else and apply or translate what you have learned in the other places to better results is also possible as part of this. Okay. So, with this we reach the conclusion of today's lecture, and tomorrow we will start looking into the major aspects of industrial engineering, and especially the main tools and other things that are associated with industrial engineering that actually gets applied in the business side, specifically in the operations, the production, the supply chain, etc. And then we will also start looking into some of the mainly used the theory behind mainly used AI techniques, which are associated heavily in the operation research, industry, systems, logistics, etc. And then once I complete that, we will do some few examples, toy examples to be frank with, and then once after that, then Dr. Prabal will come walk you through how to develop those models, maybe using Python or some or R or whatever tools that are available, or MATLAB, and using that, then how do you solve such kind of problems or open-ended problems, because in industry or specifically in business, the problems are not very well defined, they are very loosely defined. So, hence it is very critical for us to make sure that we do not mess up the design, or we do not mess up the decision process in such a way that we actually do more harm than good. Thank you for your patient hearing, and I will be back with new materials soon. Thank you very much.